Hello everyone. In this video lecture, I am going to teach you topological sorting problem. What do you mean by topological sorting problem? The topological sorting problem, it is a way in which you arrange the vertices from the directed graph. What is directed graph? Directed graph is a graph in which all edges have directions like this. You can see in the figure, this is an indirected graph, and for any graph can be traversed in two ways. One is depth first traversal ways and another one is breadth first traversal ways. And for our problem, we consider only DFS traversal. Any DFSL, if you traverse this kind of a directed graph, in case using DFS traversal, it will produce a DFS forest, something like this. Let's try to let's apply DFS traversal along this directed graph. So considering starting vertex as A. If you start from A, and I from A, I can get two adjacent vertices B and C. From A, I can get two adjacent vertices A, B and C, and among this I am considering only B right now. So let us go in alphabetical way among B, C, B. Next from B, which are the two adjacent edges? There is one is A and A is already done previously, so no more seeing that. And then we have to consider B to C. From C, is there any adjacent edges which has not visited yet? No. So that means it's over. If you come back to B again, B, is there any remaining edges which you have not visited yet? No. Then come back to A. From A, is there any unvisited vertex? No. Unvisited adjacent vertex? No. That means only this kind of path you get. And remaining are D and C. Let's start from D to E. One traversal we get. Now, let's show the remaining paths which is present in the directed graph and which is not here using a dotted lines. So A to B there is a edge. You can see a via traversal you have it. From B to A you don't have. So let me show it in a dotted ways. And C to A, C to A you don't have any, but A to C you have one edge. That I am going to show it in a dotted lines till here. And then C2 you don't have anywhere, then but D to C you have, that I'm going to show it in a dotted line. This is a Dreyfus traversal. And here one thing from the figure you can see that A is a predecessor, B is a successor. So from a successor you can get a back edge. You have a back edge to your back edge to the previous vertex, parent vertex. So this kind of edge, that means this kind of edge, back edge, creates a cycle. Normally you can identify a back edge even from the original graph itself. Moment you come to know that if there is a back edge or there is a directed cycle like this, you can you need not solve the the topological sorting problem. Instead you can just tell that topological sorting problem solution is not possible. So let's learn what's the need of topological sorting. For that, let's consider a problem of a part-time student. Part-time student has to let's understand need for topological sorting by considering a part-time students courses. So part-time student has to take up these courses, but any order. But prerequisite is that C1 C2 will not have any prerequisites. C3 requires C1 and C2, C4 requires C3, C5 requires C3 and C4. Let's model this problem in a graphical way. So that is C3, C1, C2 are independent, which has no requirement, but C3 requires C1, C2, so it is directed towards this. C4 requires C3, so it's directed this way. C5 requires C3 and C4. So this is how I've modeled, and if your model, so any problem if you model like this, it is very easy to solve it. Now let's analyze topological sorting problem. What do you mean by topological sorting problem? Topological sorting problem, it will list the vertices in such an order that for every edge UV in the graph, the vertex where edge starts is listed before where the edge ends. For example, if you have a, let's, so topological problem says that you have to arrange the vertices in a specific manner. Let's see how that can be done. So this kind of a problem is called as, that is arranging the vertices in a specific manner, is called as a topological sorting problem. This kind of a problem can be solved using two methods. One is DFS algorithm method, one more is source removal method, and